Here's another example of hypothesis test for two means independent samples where sigma 1 and sigma 2 are known. Okay, so let's take a look at this problem here. To compare the amount spent in the first 3 months by clients of two meal replacement diets, a researcher randomly selects 20 clients of each diet. The mean amount spent for diet A is $643. Assume the population standard deviation is $89. The mean amount spent for diet B is $588. Assume the population standard deviation is 75. At alpha equal 0.01, can the researcher support the claim that the mean amount spent in the first 3 months by clients of diet A is greater than the mean amount spent in the first 3 months by clients of diet B? Okay, so let's go ahead and summarize what's given that might help us put in the pieces. Okay, so we've got two diets here. We have diet A and diet B. Okay, so the mean amount spent for diet A was $643 with an assumed population standard deviation of 89. Okay, and that sample size was 20. Okay, for diet B, the sample mean was given to be 588 with an assumed population standard deviation of 75, and its sample size was also 20. Okay, so because we've got two independent samples where both standard deviations are assumed to be known, we're going to go ahead and use the z-test for this. Okay, so the first thing we want to do is write the claim in terms of the parameters mu sub 1 and mu sub 2. Okay, so the claim is that the mean amount spent in the first 3 months by clients of diet A is greater than that of diet B. Okay, so in terms of mu sub 1 and mu sub 2, this will be mu sub 1 greater than mu sub 2. Okay, so this is the researcher's claim. So because this does not contain the case of equality, this makes this the alternative, which forces the null to be less than or equal to mu 2. So this is an upper tail test. Okay, let's go ahead and find the standardized test statistic. I'm going to go ahead and do this completely in the calculator. The previous example I put in to the course, I did it both by hand and with the calculator. But let's go ahead and find our standardized test statistic just by using the calculator. Okay, so I want to go to Stat, right arrow over to Tests, and I want to select the two sample z-test. And again, I could either have the 2 columns of 20 values or the summary statistics. Okay, this null parameter here from the hypotheses I want to keep as 0, because remember, an alternative way to express this is, oops, I forgot the sub 1, mu sub 1 minus mu sub 2 is less than or equal to 0. Okay, so on the right side of this inequality I have 0. So we're actually testing whether or not there is a difference between these two means. Okay, so I want to leave that at 0. Oops, I selected the wrong test. Ah! Okay, so I want the 2 sample z-test. Okay, I selected 2. Okay, much better. Okay, so I want to put in my assumed standard deviations. Okay, so my first one is 89, and my second one is 75. My first sample mean was 643 with a sample size of 20, and my second one was 588, also with a sample size of 20. Okay, so again, I can go ahead and change my direction of alternative. Okay, and then I want to select Calculate. Okay, so for this problem, I get a standardized test statistic of about 2.11. Okay, if we were to be finding that standardized test statistic by hand, remember the formula has x bar sub 1 minus x bar sub 2 minus mu sub 1 minus mu sub 2. Okay, so this part is what we want as 0. Okay, so that's what we were going to do by hand. Okay, so I did a previous example of that. And then in the denominator, we've got the sample variances like so under the radical. Okay, so if I were to do that part by hand, of course I'd be putting in x bar sub 1, x bar sub 2. I should come out with 2.11. But I went ahead and found that standardized test statistic in using the TI. Okay, so let's go ahead and look at this corresponding p-value. Okay, the p-value is about 0.0173. Okay, so let's go ahead and compare the p-value to our level of significance. Okay, our level of significance given in the problem was 0.01. Okay, so looking at this p-value is greater than our level of significance, okay, just by a smidge. So we're going to fail to reject the null. Okay, so what that means in terms of supporting the claim is that we are not going to support the claim. Okay, because we are failing to reject the null and the claim is the alternative, we're going to state at an alpha level of 0.01 there is insufficient evidence to support the claim that the mean amount spent for diet A is greater than the mean amount spent for diet B. Alright, so let's go ahead and take a look at the critical value. I know I did this out of order. Okay, in your lab I had you do the critical value first, but that really doesn't matter. Okay, so I want 0.01 area in this upper tail, okay, because this is an upper tail test, and I could go ahead and find that critical value using my inverse normal function in the calculator. So I'm going to go to distribution, select 3. Now it's expecting a cumulative area. That cumulative area is 0.99. So my the only critical value here is 2.33. Okay, see that with rounding. Now if you wanted to use the standard normal table in the text, you would find the as close as you can get the area of 0.99 in the body of the table and read outward to find that corresponding z-score. If you went ahead and inputted a value of 0.01 in the inverse normal function in the calculator, you would have gotten that negative critical value, and you'd have to remember to take the opposite because this is an upper tailed test. Okay, so looking at our standardized test statistic of 2.11, okay, we're in the fail to reject region. Okay, but we're somewhat close. Okay, the test statistic of 2.11 is reasonably close to 2.33. So look at our p-value versus our level of significance. These are somewhat close in value. Okay, so this area here, the p-value would be going this way, is greater than our level of significance. Okay, but we're not failing to reject strongly. For example, if this level of significance were 0.05, then that p-value would be less than our level of significance and we would be rejecting the null. And that's reflected with our test statistic being close to our level of significance with our critical value. Okay, so the decision is to fail to reject the null, and the question is there enough evidence? Can we support the claim that the mean amount spent in the first 3 months by clients of Diet A is greater than the mean amount spent in the first 3 months of Diet B? Okay, so there is insufficient evidence to support the researcher's claim that, okay, then you'd restate all of that part in plain English, okay, that the mean amount spent in the first 3 months by clients of Diet A is greater than the mean amount spent in the first 3 months of clients of Diet B. Okay, I would actually prefer to type this because it's much faster for me to do so. And one last thing, because we failed to reject the null hypothesis, it is possible we did that in error. So a type 2 error may have occurred. Okay, now I did go over how to get the corresponding confidence interval in my previous example. You are welcome to go ahead and take a look at that. You would go to the 2 sample z interval in your calculator.